So welcome to this session. In this session, we are going to introduce the concept of ordinary integrals for vectors. So I'll give the definition and do an example to illustrate how to compute such integrals. So to define an ordinary integral of a vector, we need to define a vector in space. So let this be a vector depending on a single scalar variable u, where R1 of u, R2 of u, and R3 of u are supposed to be continuous in a specified interval. Then we define the integral of this vector R of u with respect to u as I integral of R1 of u du plus j integral of R2 of u du, and then plus k integral of R3 of u du. And this is called an indefinite integral of R of u. So that's what defines an ordinary integral of a vector function R. Now, if there exists a vector S such that when we integrate this vector R of u, we get integral of d du of S of u which gives S of u plus constant c. I remember that in this integral, we need to add a constant of integration c, but which is a vector. This constant here is also another vector. So where C is an arbitrary constant vector, independent of the variable u. Now we can also define the definite integral for vector functions, just as we do in calculus. So the definite integral integral from a to b of this vector r of u du is the integral from a to b of d du of s of u du, which is s of u plus this constant vector u from a to u equals to b, and this simplifies to s of b minus s of a. So now let's do an example to illustrate how to work out these ordinary vector integrals. So example, if this vector r of u is given by u minus u squared I plus 2u power 3j minus 3k, find so there are two questions. One, integral of r of u du. Two, integral from 1 to 2 of r of u du. So part one's solution integral of r of u with respect to u will be given by the integral of u minus u squared I plus 2u power 3j minus 3k, then with respect to u, which can be written as I integral of u minus u squared du plus j integral of u 2u power 3 du plus k integral of minus 3 du. This will be given by, when you work out this integral, you get I into u squared over 2 minus u power 3 over 3 plus constant of integration c1 plus j into, so I'll have u power 4 over 4, so 2 over 4 is 2, so u power 4 over 2 plus c2 plus k into minus 3u plus C3. So this will give us u power 2 over 2 minus u power 3 over 3 times I plus u power 4 over 2j minus 3uk, and then plus C1I plus C2j plus C3k. And then this C1I plus C2j plus C3k can just be written as vector C. So therefore, the integral of R of u du is nothing but u squared over 2 minus u power 3 over 3 I plus u power 4 over 2 j minus 3uk plus this constant vector, where, to be specific, this C is given by C1I plus C2j plus C3k. So that is the answer to the first part of our problem. Part 2 is to find now the integration of the same vector function, but in the interval 1 to 2. So integral from 1 to 2 of R of u du. Now, this will just be the same as, because we are dealing with the same vector function and we have the answer here, we have u squared over 2 minus u power 3 over 3 I plus u power 4 over 2j minus 3uk plus C vector u from 1 to u equals to 2. So putting in the upper limit, we'll have 2 squared over 2 minus 2 power 3 over 3 I plus 2 power 4 over 2j minus 3 times 2k plus C minus lower limit will be 1 squared over 2 minus 1 power 3 over 3 I plus 1 power 4 over 2j minus 3 times 1k, and then plus C, which is the constant vector. So this we get 2 squared over 2 is 2. Minus 2 power 3 divided by 3 gives us 8 over 3. And then minus, I just want to put I terms together, half. Minus minus is plus 1 over 3. So this will give me the I components. J, I'll have 2 power 4 divide 2, which is 8, minus a half. Then for K, so this is minus 6, and then minus minus plus 3, K. Remember, constants cancel, sub C minus C is 0. So then 2 minus 8 over 3 minus a half plus a third gives minus 5/6. So this will give us minus 5/6 I. H minus a half gives 15/2 J. Then this is minus 3 K. So this is the final answer to that given problem.